All right, this is our third foray into building the Space Dodger in PyGame. And what we're going to do this time is we're going to add the ability to randomly add uh, obstacles. We'll do collision in another one, but what you're going to see here is we're adding the obstacles will also include leveling, that after you get to a certain score, that it will start adding objects randomly. And if you'll see, this time I ran it, it started off with 2 satellites and an astronaut. If I run it again, now it's picked an astronaut, an asteroid, and the satellite. And so we're going to look at, in my case, I've got 4 images, and we're going to choose between the 4 of them. The images that I use with transparent backgrounds is out on the GitHub, listed in the description, along with the code as of it is when we finish going through this today. So let's take a look. We're going to build a class. We've got our class stars that we use for our star field. We got our class ship that we use to create our ship and move around. So now we're going to have a class called obstacle. Our first definition function method is going to be def underscore underscore init underscore. We're going to pass in self. We're going to pass in screen width. We're going to pass in screen height. And then before we get here, because if we don't add these images to our project first, it's going to be like, what's all of this? And so we're going to jump down here to where we have our images. You should see in yours, if you've been following along, you've got all of our ship images. And we're going to now have some obstacle images. And I kind of used a comment to say this is my image section. I used a comment, these are one of the ship, these are one of the obstacles. And so what we're going to do is, if you use my 4 objects, you're going to put them in the same folder that your Python code is in, and then we're going to create 4 image variables. We're going to do asteroid pygame image load asteroid.png.convert to alpha. Make sure you have those parentheses on the end, because that is a function that we're calling. We're going to do the same thing for astronaut. Load the astronaut PNG, satellite, sat PNG, alien, alien PNG. And then we're going to do just like we did with our ship. We're going to transform the images to the heights we want. Again, this is so I can use images of any size, and I can make sure, regardless of what the image I use, it's the size I want in the game. So basically, we're going to pass in, we're going to transform alien, we're going to scale it. We're going to say we're scaling alien, and in parentheses, we're going to have new width minus 10, new height minus 10 with a comma in between. Same thing with asteroids, it's going to be new width, new height plus 50. Astronauts, new width, new height minus 50. And then the satellite is new width, and then we're only adjusting the new height because um, this is my object that's not square. And if you'll remember, we created in the first one, maybe the second lesson, we created these variables, new width, new height, that are created from base size when it figures out how big the game is being played on. So now that we have our images imported into the project, we're going to go back up here, and we're going to say we want a random choice. In my case, so it's random choice, parentheses, brace, because brace is going to tell us that we're having an array. And what I'm going to do is, because I want astronauts and asteroids to appear more often than I want the satellites and aliens, I want to pass astronaut, comma satellite, comma alien, comma asteroid. So in theory, astronauts and asteroids should appear twice as much as satellite and alien. We're going to say the image is the result of our random. We need to get the rectangle of our image so that we can place it on the screen, and also it's going to be important for our collision. We're going to go ahead and do this self.mask, which is pygame.mask from surface, and it's getting the mask from the image. And this is going to be what we use specifically to do our collisions. And then we're passing the screen width, screen height. We want to set the X, which is left and right on the screen. We want it to be somewhere between the 0, which would be the left side of the screen, screen width, that would be the right side of the screen. But it's important that we subtract the width of our object so that our object doesn't appear half off the screen. And then we're going to do self y is minus rect height, which basically means that we are going to start all the way at the top of the screen uh, every time. And then the speed we're going to pass in, we want to go somewhere between the speed of 4 and the speed of 6, which means the slowest speed of our objects will be the fastest speed of our stars. Okay, so that's the method that helps us initialize an obstacle. Then we need to move the obstacle. So we're going to do definition, move, in parentheses, we're going to pass self, and then basically our self.rectangle y position, self.rect.y. We will add the self speed. We use the plus equals because that says add the speed and give me set it to the sum. And so it's basically the equivalent of saying self.rect.y equals self.rect.y plus self.speed. And so basically if our speed's 6, it's going to look at the y and it's going to each frame move it down 6 pixels. And then we want to check and see if it has gone off the bottom of the screen. So we're going to do if self.rect.top. That means that the top of the obstacle is greater than the self.rect.height, our self.screen height. Then that tells us that we have now gone off the bottom of the screen. And so it's going to say, let's reset the Y to off the top of the screen. And then we're going to again randomly select somewhere between the left side of the screen and the right side of the screen. And we're going to randomly set the speed again. And then we are going to, I need to comment out this code for now because this will be used when we do our scoring. And so we'll come back to that. And then we need to draw on the screen, and basically we're just going to pass the image in its current location. And then this is a method we're going to use when we have a collision. We're going to add shields, and if there's a collision with the shield, it's going to destroy the obstacle, and this is basically going to reset the location of that. And so that's def reset location, passing in self, and then it's again going to set the rectangle's y to 0. It's going to set it randomly left or right on the screen. Okay, so we've built our methods to create the obstacles and to move the obstacles. We've imported our images. We've transformed our images. And then basically, just like we instantiated our star field and we instantiated our ship, we're going to create a collection called obs. And that is we're going to pass in obstacle, or we're going to create an obstacle. We're going to pass in screen width and screen height because that's what's required. And then we're going to do 4 underscore in range 3. So what this means is it's going to create 3 obstacles. And then down here, all we have to do is say for ob and obs. So it's just going to go through, it's going to say for each obstacle there is. And we do it this way because as we level up, there might be 3 objects. There are obstacles, there may be 15 obstacles. And so this is basically saying for each obstacle in the collection of obstacles, we're going to move it, and then we're going to draw it, and be sure when you do the dot draw that you pass the screen. And so we'll see when we hit play, it creates my 3 objects. As you can see right now, we have no collision. And something else just to keep in mind, if you'll notice, the obstacles are on top of the stars, the ship is on top of the obstacles, and it's very important that the order in which we draw things on the screen is the way they will appear furthest back. So the star field's drawn first, so it's the furthest back. The obstacles are drawn next, so they're in front of the stars. the ship is drawn last, and so it's in front of the stars and the obstacles. And just going back up to this code, I could change this to 5 if I want to start with 5 objects. And that simply, I now have 5 objects to move around. What we'll do next time is we will look at how to get collisions with these obstacles. Please like and subscribe and join us when we get together again. Thank you.